So let's identify the components. That's the hydraulic tank over there. That's a hydraulic oil stored inside the hydraulic tank. There we have the hydraulic hose which connects towards different components. That's a hydraulic pump, and that's the main relief valve over there. You can see the manually activated valve block lever there. That's the valve block. So the valve block and the internal galleries of the valve block. There we have the hydraulic ram, or it can be called as an actuator. Then it comes the filter, the return line filter, and also the strainer inside the hydraulic tank. So now let's see case 1, how it exactly works. Case 1 is neutral circuit. You can see the internal galleries of the valve block is changing into neutral circuit. In neutral circuit, no work is happening. The oil goes through the strainer, sucked by the hydraulic pump, and it goes to the main relief valve, and the neutral circuit gets to the return line and gets filtered and gets back to the hydraulic tank. So that's what's happening in a neutral circuit. No work is happening. And let's see the case 2. In case 2, we activate the lever so that the galleries of the valve block changes to service activation mode. So service is getting activated. So now let's see how it works. The oil gets through the strainer, gets filtered, and the pump sucks the oil. It passed through the main relief valve, and you can see the path of the oil. It gets into the head side of the hydraulic ram. It pressurizes the piston on the top, so the piston moves down due to the pressure, and through the rod side the oil escapes to the return line and get filtered and gets back to the hydraulic tank back. So that's service activation mode.
The simplest vane pump is a circular rotor rotating inside of a larger circular cavity. The centers of these two circles are offset, causing eccentricity. Vanes are allowed to slide into and out of the rotor and seal on all edges, creating vane chambers that do the pumping work. On the intake side of the pump, the vane chambers are increasing in volume. These increasing volume vane chambers are filled with fluid forced in by the inlet pressure. Inlet pressure is actually the pressure from the system being pumped, often just the atmosphere. On the discharge side of the pump, the vane chambers are decreasing in volume, forcing fluid out of the pump. The action of the vane drives out the same volume of fluid with each rotation.
This video shows a fully automated process of assembling housing components in airbag manufacturing, which uses a simple pneumatic system. The energy source of this type of system is a pump or a compressor, and a storage tank which holds the air. The pump of the compressor may be driven by an electric motor or by a portable internal combustion engine. Pneumatic systems are designed to use the air from the tank perform a certain work function, typically a punch press run. The load part functionally changes the mechanical energy of air into linear motion which drives the punch press ram. Pneumatic load devices can also be used to produce rotary motion and striking blows for hammering.
This video shows a full automatic pad printing machine for Golf T, which uses a heating press. Speaking from the circuit principle, the heat transfer device or heat press is a machine which is controlled by a temperature controller and time controller together. Temperature and time can be preset. Heating temperature of the device does not set the value of the disorder. The power will cut down when reach the settlement time. According to different products, the fiber body will make shape as cylindrical, square flat, round face to transfer different products. This video shows an automatic temperature controller device used in a certain water treatment station. This device automatically detects and shows the temperature of the water sample. It also measures the pH of the water being treated as well as the chlorine content of the water sample.
This video shows a level determination system that is controlled by the weight of the container. Desired level or weight is set on the controller of the machine, which will be the desired weight for every container with a certain margin for error. When the desired level or weight is achieved, a corresponding output signal will be developed which will activate the liquid control valve to stop filling the container. When the operation is already completed, the conveyor will move the filled container forward and the next container will be positioned immediately for filling. This video shows some possible application for photoelectric capacitance sensor. Photoelectric sensors use a beam of light to detect the presence or absence of an object, as well as the quality of the object, whether to reject it or not. This technology is used to identify an object size and contrast. This sensor specializes in micro, amplifier built-in, power supply built-in, U-shape, cylindrical and liquid level photoelectric sensors. Each type is widely applied across various fields of industry, including industrial automation lines, elevators, parking facilities, logistics services, semiconductor devices, packaging machines, and construction areas. It also provides microwave motion and active infrared presence detection, and has the ability to reject pedestrian traffic and vehicular cross traffic, and can discriminate between small and large objects.
This video shows an insertion flow meter used to measure flow quantities in a pipe. As we can see in the display, it displays the mass flow rate, the totalized flow, and temperature, as well as providing a graphical percentage at full scale. In addition, there is a reading in milliwatts in the top left corner, which represents the raw calibration output. It can be used for diagnostics, and most importantly, it can be used to verify the calibration of the insertion flow meter during calibration process.
A production plant that makes pharmaceutical products. Dräger designed a gas detection system for the company's hazardous goods stores and production facilities. Dräger combined its precise knowledge of gases and vapors and years of experience in gas detection technology when designing and building this system. The gas detectors are installed at critical points and connected to the central control system, resulting in a gas detection system which is as efficient as it is cost-effective. Gas detectors continuously monitor for changing gas concentrations. A modular central control system from Dräger analyzes the measurement results. If gas is escaping, the system immediately gives an audible and visual alarm to alert personnel to the danger. For example, when the wastewater is contaminated with solvents, and there is a hazardous concentration of combustible gases in the raking hall, in a matter of seconds, the gas concentration is identified. Personnel in the affected area are warned immediately, and the doors open automatically. The gas concentration is diluted by the influx of air, thus ensuring that an explosive mixture does not form.
pH is one control parameter which tells you whether your sample is as required. This pH module enables the detection of pH alongside or in addition to analytical determinations from exactly the same sample. It is equipped with an automatic cleaning routine, a 3-point calibration and a resting position. The entire operation from getting the sample up to measuring the pH of the sample is fully automated.